So on Tuesday of this week, we ended with this problem, and actually we're on the next page. You may find that you will need some patty paper if you don't have any still. And if so, the box of patty paper is on the student desk next to the teacher desk. It's in the blue box. What we're talking about, if I would give each of you a number on my scale factor number line, and we would put in the 115-degree angle. The question that was asked was, would we get similar triangles? That would be triangle like ABC, for example, and let's say ADE, or AFG, and so on. Will these triangles be similar to each other, and if so, by what reason? And the conclusion we came up with is that they all share angle A, and they also all have a 115-degree angle. And because of that, that means the third angle, the top, has to be the same. So therefore the triangles are going to be similar because they have the same angle measurements. So the question, again, we talked about this on Tuesday. So what the triangles similar to each other, so hopefully we decided the answer was yes. And we also saw the fact that they were all similar to each other because of the fact that they all share the same three angle measurements. I kind of left off with number 7, where I was posing the question, could I choose any point along M, which that construction is below this problem 7. And so I'd like you to begin here, and if you would go ahead and answer questions 6, 7, 8, and work on problem number 9. Again, sheet of patty paper will be helpful. There are also rulers available at the student desk if you need a ruler as well. And then turn the video back on when you are ready to continue. All right, so the key here is, problem number 6 is the fact that the scale factor is the same. So on the first day of 7.2, I asked you to do a 1.5 scale factor on one side and a 2 scale factor on the other side and connect those 2 points. And what we found was the triangles weren't the same. They had different angle measurements. But when I made the 2 numbers like 1.5, 1.5, or 2 and 2, or make the scale factors the same on both sides, what ended up happening was I got triangles that had the same 3 angle measurements. So why, for side angle side, why is it important to scale both the triangles? Because similar triangles will only occur if the scale factors are the same. Scale factor is the same number. So in other words, if I'm using 2 and 2 in these triangles, and if all the scale factors are 2, we should end up with triangles that will be similar to each other. So at the bottom, I ask you to choose a point M. It's your choice where you want to place point M, or point that point along M, and then use a sheet of patty paper. If you trace a 65-degree angle, do we get triangles that are similar to each other? And then ask you to repeat it a second time, same thing, trying to come up with triangles. Again, are these triangles similar to each other? If I using A as my common angle, and then they all have a 65-degree angle along M. So I'm hoping you decided the answer here is going to be yes, for the same reason it was yes on the previous page, which is the fact that the triangles all have the same 3 angle measurements. Whatever A is, the angle along M, which is all 65s, and then the angle at the top, which will be the same because we have a triangle rule. This states that 3 angles must add up to 180 degrees. So the next page we're going to look at a different situation where we have angle side. So again, the difference between angle side angle is if I have a side and then off of the side I'm working with, that's where I construct the angles. That's called angle side angle. Angle side means that I have a side, I'm creating an angle off of one side, and then I'm creating the other angle off of another vertex that is not the vertex of the given segment, so it's a different location. And so this is an example of angle side. So in this problem here, they're asking you, again, to try to decide if this will work or not. So the side is here, for example. So we have 77 is the angle, followed by the A angle, then the side next. So they're asking you to use your protractor or the patty paper in this case, and try to decide if these triangles are going to be similar to each other. Go ahead and complete that, turn the video back on when you're ready to continue. So if I would take my patty paper and do another 77-degree angle, and another 77-degree angle, and if I continue to do that, what I'm going to have is the same situation we talked about throughout this package. Is I have two triangles in which two of the angles are the same. They all share angle A, and this is again creating nested triangles here. They all share an angle A, and then the angles along M are all 66. And what we aren't really worried about is the length of the side, because even though AB is the given side, and then AD becomes the next side, what's the scale factor? We don't know. But is it even necessary to know the scale factor? And in this case here, the answer is actually no, because all three of these triangles share all three angles, so the triangles have to be similar because the angles are the same. It goes back to our first discussion about similar shapes, is that are all the angles the same? And then with triangles, unlike rectangles, and then the next thing becomes the shape. And the shapes here definitely are the same in terms of triangles, and the scale factor here doesn't play as big of a role because there's only one pair of sides that are being compared. So for this particular rule, we have an angle side situation and an angle situation. The side actually becomes really insignificant. It's not important at all, because to compare ratios, and like inside angle side, the first one, I have two pairs of sides, and so I got to make sure the scale factor is the same number. But here, there's only one pair of sides, so I'm not comparing the side ratio to anything else. So if it's 2.5, then it's 2.5, but it doesn't change the fact that all the angles are going to be the same because they both share two angles to begin with. So this rule is actually called the angle rule, because the sides don't matter when there's only one pair. And we don't call it an angle rule because if two pairs of angles are already equal, the third pair is automatic. So we only need to check two pairs. So for the last problem, it's side. And we've done construction with compass. One of the few constructions we've done with compass, where we actually made side triangles. But to make this a little bit easier, I went ahead and created the triangle on the next page. So the question here is, could the triangles on the next page be checked using side or angle? And if you could, which rule would you use? How would you check? Going back to problem 12, how would you check to see if they're similar to each other? How can the ruler or patty paper help? So go ahead and take a look at problems 12 through 14. Use the problems on the next page. The triangles on the next page to complete the task. In terms of the final questions, we will not be addressing A at this time because we're doing this, the chapters a little bit in order this year, and so congruence patterns will show up in our discussion in January. When you're finished with the side activity, turn the video back on. So how would you check to see if the triangles are similar? And the answer is angles. We need to check the angles. And that's why I'm asking the second question, 13. Could you check the triangle on the next page using side angle side or angle angle? And the answer is yes. Because if we're going to accept that first pattern we looked at, if the triangles have a pattern of side angle side and they have shared side ratios, then the triangles are going to be are copies of each other or dilated copies of each other. And if they have two equal angles, then the third angle has to be the same. So angle angle will definitely work as well. Which one will you choose? That is really your opinion. Which one you prefer? You have the triangles. It says using the pattern in problem 13, whichever one you've chosen. Are the three triangles on the next page similar to each other? So, for example, if I would have chosen side angle side, I would probably would have checked these angles here to see if they're the same. And then the sides that I'm looking at are these two sides here for side angle side. The thing about this activity, the sides are already done for you. It's a side pattern. So from here to here and here to here, they're being doubled. And if I'm going from the first triangle, or original triangle, to the smallest triangle, each of the sides are half. And if I'm going from the original triangle to the last triangle, the sides are 1.5 times. So they're already set up to be that scale factor. So all we got to do is really check an angle. And so if all the bottom left angles are the same, the triangles will be similar by angles, side angle side. If you decide to check two angles, and again, it's just any of the two angles, if these two angles, the ones in blue and red, the ones in blue are the same, the ones in red are the same, then that means angle angle would be a verification that these triangles are similar to each other. So back to the previous problem, are these triangles similar to each other? Hopefully you found, whether you use the side angle side pattern or the angle angle pattern, that they do have shared angles. And therefore, because the sides have the same scale factor, the triangles will be similar by either side angle side or angle angle, depending on which pattern you chose. Now Euclid, who's the geometry we're studying, he would quite often try to prove something new by using something that we previously had already proven or accepted. So one of the reasons we can use side, 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 prove side, side, side is we could use something that we previously have already shown to be true, or at least we're going to accept to be true, and then use that information to be able to prove something else. That's what we did here. All right, so the three patterns we're going to be using for similarity, these are the three patterns for your book, is side, 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 angle, side, and angle, angle. You may be wondering what that little symbol is after the letters. We have a congruent symbol that was introduced to you back in chapter 1, and that symbol really is broken into two parts. The equal sign basically means all of the corresponding measurements are the same numbers. That's angles and sides. And this symbol here is saying that the triangles, or the shapes themselves, if they're not triangles, have the same shape. So same shape and same size. So this would be the same shape, and this would be the same size. For similarity, we only use the top part of the congruency symbol, which says that the shapes are the same, but their sizes may not necessarily be the same. So last two problems here, I'm trying to set up a Bush conjecture, and then trying to figure out if the shapes are similar or not. I'd always recommend looking for angles first, because you probably will find that angle angle is the one that we use the most. So angle angle is actually going to work here because the two pairs of angles that are marked are the same. And if you look at problem B, you make a similar decision. If you don't have two angles, then you got to look at side angle side or side side side. This problem here, we need to solve for G, so I'm going to circle the second triangle. The 9 and the G get paired together, and the 6 and the 4 get paired together. So I'm going to set up the proportion this way. where 6 goes to 4 and 9 goes to G.
Cross multiply and you solve, no problem.